There is a $2 length of black PVC pipe mounted on any south-facing wall that pulls cool air through your entire home without consuming a single watt of electricity, without a compressor, without refrigerant, and without a monthly electric bill that doubles every summer while the temperature outside climbs past 100 degrees. No window unit rattling through the night. No central air conditioning system that costs $5,000 to install and $200 per month to run. No service call from a technician who charges $150 just to walk through your door. Just a black pipe mounted vertically on a sun-exposed wall that uses the heat of the sun to create a thermal draft that pulls fresh, cool air from the shaded north side of your home and pushes scorching hot air out the top. The same way a chimney pulls smoke out of a fireplace, except instead of removing smoke, it removes heat, continuously, silently, for free. Every single day that the sun shines, Oak Ridge National Laboratory tested passive solar chimney cooling systems and documented interior temperature reductions of 10 to 15 degrees Fahrenheit in test buildings using nothing but thermally induced airflow. The Department of Energy published research confirming that passive cooling techniques, including thermal draft systems, can reduce residential cooling loads by 25 to 50% annually. Researchers at the University of Queensland published peer-reviewed data confirming that solar chimney airflow rates match or exceed mechanical ventilation systems in hot climates during daylight hours. This is not a fringe idea from an off-grid blog. Ancient Persian engineers built wind towers and solar-driven ventilation systems that cooled palace complexes in 120-degree desert heat over 3,000 years ago without any mechanical assistance. Roman architects designed buildings with thermal draft ventilation that kept public buildings comfortable through brutal Mediterranean summers 2,000 years before air conditioning was invented. Traditional architecture across the Middle East, North Africa, India, and Central America has used solar-driven passive cooling for thousands of years because in those regions, surviving summer was not optional. Then, a $130 billion air conditioning industry decided something very important. They decided that cooling a home is a mechanical problem, requiring a mechanical solution that consumes electricity and generates monthly revenue forever. They did not abandon passive cooling because physics stopped working. Thermodynamics has not changed since the Persians built their first wind tower. They buried it because a $2 pipe that uses the sun to cool your home cannot be sold to you as a service contract, a refrigerant, recharge, or a $5,000 equipment replacement. This is the story of the oldest cooling method on Earth, and the industry that replaced it with a machine and a monthly bill. If you are not subscribed yet, hit subscribe and the bell right now. What they buried, we dig up. Every single video. Travel back with me to 500 BC, the ancient Persian city of Yazd, located in the center of one of the hottest inhabited deserts on Earth. Summer temperatures in Yazd reach 115 degrees Fahrenheit. The air is bone dry. The sun is merciless. And yet the city has been continuously inhabited for over 7,000 years. People live here, they work here, they raise families here, in the middle of a desert that would kill an unprotected person within hours. How? Persian engineers built towers on top of every building called badgers, wind catchers. These structures rise 15 to 30 feet above the roofline and are open on multiple sides to capture prevailing breezes. But the badger is only half the system. The other half is underground. Beneath many Persian buildings run Qanat channels, underground water tunnels that carry cool water from distant mountains through the earth to the city below. The bagir captures hot surface air at the top. That air flows downward through the tower and across the underground water channels, where it drops 30 to 40 degrees in temperature. The cooled air then flows through the building at ground level and exits through openings on the shaded side. The building is air-conditioned. The temperature inside stays between 65 and 75 degrees, while the desert outside bakes at 115. No electricity, no compressor, no refrigerant, just the temperature difference between the surface and the underground and the physics of air movement through a vertical shaft. This system has been operational in Yazd for over 2,500 years. Some of the original Bagir structures are still functioning today, still cooling buildings, still using the same thermodynamic principles they used when Persian kings walked those streets. Now move to ancient Rome. The 1st century Roman architects designing public buildings understand that hot air rises. Every room, fire, every heated bath, every sun-baked surface proves this daily. They design buildings to use this movement deliberately. South-facing walls are built taller and darker to absorb solar heat. Interior shafts draw the heated air upward and out through roof openings. As hot air rises and exits, cooler air from shaded courtyards and underground passages is pulled in to replace it. Roman bath complexes in particular demonstrate this principle at enormous scale. The hypocaust heating system that warms floors also creates thermal drafts that manage air circulation throughout the building. Hot air rises through wall cavities and exits through roof vents. The movement of that air constantly draws fresh air through the system. Vitruvius, the Roman engineer, whose work defined Western architecture for 1,500 years, wrote extensively about orienting buildings to use natural air movement for cooling. He documented specific design principles for creating thermal draft ventilation that we would recognize today as passive solar chimney cooling. Published nearly 2,000 years ago, available to anyone who reads Latin or any of the hundreds of translations, now arrive at the modern era. 1956. A physicist named Trombe and an architect named Michel, working in France, develop what becomes known as the Trombe wall, a south-facing dark-colored thermal mass wall with glazing in front and vents at top and bottom. The sun heats the dark wall through the glass. The wall heats the air between the glass and the wall surface. The heated air rises and exits through top vents, drawing cooler air in through bottom vents. The entire house ventilates passively, using nothing but solar energy and convection. Trombe walls have been built across southern France, the American Southwest, and hot climate regions globally since the 1960s. The Department of Energy includes Trombe wall design in its official residential energy efficiency guidelines. This is documented, tested, published, and entirely ignored by every HVAC contractor you have ever met. Now stay with me, because the modern physics behind this $2 pipe is where the story becomes undeniable. The pipe is a solar chimney, a vertical black PVC pipe mounted on a south-facing wall, sealed at the bottom with an air intake vent and open at the top. Black absorbs up to 95% of solar radiation. On a hot summer day, the pipe surface temperature reaches 140 to 160 degrees Fahrenheit in direct sun. Here is the physics. Hot air is less dense than cool air. When air inside the pipe heats up, it becomes buoyant. It rises. It exits through the open top of the pipe. This rising hot air creates a low-pressure zone at the bottom of the pipe. Outside air rushes in to fill that low-pressure zone. But the intake is positioned on the shaded north side of the building, where temperatures are 15 to 25 degrees cooler than the sun-baked south side. Cool air enters from the north, flows through the living space, gets drawn into the base of the solar chimney, rises through the heated pipe, exits from the top. The house ventilates continuously as long as the sun heats the pipe. This airflow is measurable. A 4-inch diameter solar chimney 6 feet tall generates airflow rates of 30 to 50 cubic feet per minute, according to testing published in the journal Renewable Energy. A 6-inch pipe 12 feet tall generates 80 to 120 cubic feet per minute. For reference, a standard residential ceiling fan moves approximately 100 to 200 cubic feet per minute on its highest setting. A 12-foot section of 6-inch black PVC pipe costs approximately $12 at any plumbing supply store. Add basic fittings and a screened intake cap, and your total material investment is $15 to $25. For a system that moves as much air as a running ceiling fan continuously throughout every sunny day without consuming a single watt. The Oak Ridge National Laboratory study I mentioned earlier documented interior temperature reductions of 10 to 15 degrees Fahrenheit in test structures using solar chimney ventilation. That is the difference between a home that feels unbearable and one that feels livable without any mechanical cooling system running. 10 to 15 degrees of free cooling from a pipe mounted on a wall. So, if solar chimney cooling is documented by Oak Ridge National Laboratory, published by the Department of Energy, peer-reviewed in multiple academic journals, used successfully for 3,000 years across the hottest inhabited regions on Earth, and costs $15 in materials, why does every HVAC contractor recommend a $5,000 air conditioning system instead? Because the $130 billion air conditioning industry depends on one fundamental assumption: that cooling requires electricity. That electricity requires a utility bill, and that utility bill requires you to remain a paying customer forever. The United States residential air conditioning market generates approximately $15 billion in equipment sales annually. Add installation, maintenance, repair, and the electricity that powers these systems, and the total annual expenditure by American homeowners on cooling exceeds $30 billion per year. Over a 30-year homeownership period, the average American household spends $40,000 to $80,000 on air conditioning alone. Equipment purchases, replacement cycles, maintenance contracts, refrigerant recharges, and the electric bills that arrive every month from June through September without mercy. A solar chimney eliminates the majority of this expenditure, not by providing the same intense cooling as a central air system on the hottest day of the year, but by reducing cooling demand so dramatically that many homeowners in moderate climates can eliminate mechanical cooling entirely, and those in extreme climates can reduce air conditioning runtime by 50 to 70%. A 50 to 70% reduction in air conditioning runtime represents $600 to $1,400 in annual electricity savings for the average American household. Over a 10-year period, that is $6,000 to $14,000 recovered from a system that costs $15 in materials and one afternoon of installation. The HVAC industry knows this. The physics is in every thermodynamics textbook published in the last 100 years. The performance data is published by the Department of Energy. The ancient precedent is documented across every culture that survived in a hot climate before electricity existed. They simply never told you, because telling you would cost them your electric bill, and your service contract, and your refrigerant recharge, and eventually your equipment replacement. The entire revenue stream disappears the moment you mount a black pipe on your south wall and open a window on the north side. I need to be honest with you here. A solar chimney is not a replacement for air conditioning on the hottest days of summer in Phoenix or Houston. When outside temperatures exceed 100 degrees and humidity is high, passive ventilation moves hot, humid air through your home rather than cooling it. On those days, mechanical cooling is more effective. Solar chimney cooling works best in climates where daytime temperatures are high, but nighttime temperatures drop significantly. Desert climates, high-altitude regions, Mediterranean-type climates. In these environments, the solar chimney ventilates the home during the day, and cool night air purges the accumulated heat each evening. In very humid climates like the Gulf Coast, moving outdoor air through the home can increase indoor humidity and discomfort. In these regions, solar chimneys work best in combination with ground-level shading and careful management of when windows are open versus closed. And the system only works when the sun shines. At night, the thermal draft stops because there is no solar heating of the pipe. Nighttime cooling requires either opening windows for natural ventilation or supplemental mechanical cooling. But here is what a solar chimney does exceptionally well for the majority of hours in the majority of hot climates. It provides continuous free ventilation during the peak heat hours of every sunny day. It reduces indoor temperatures by 10 to 15 degrees compared to a sealed, unventilated building. It eliminates the stuffiness and air stagnation that makes hot buildings feel unbearable even before the temperature becomes extreme. And it operates for decades with zero maintenance and zero energy costs from a $15 investment. Here is exactly what to do starting today. Buy a 6-foot section of 4-inch diameter black ABS or black PVC pipe from any plumbing or hardware store. Cost approximately $5 to $8. Buy a screened cap for the bottom intake end. Cost approximately $2 to $3. Total material cost for a basic system, $7 to $12. Mount the pipe vertically on your south-facing wall. The bottom of the pipe should be at or near ceiling height inside the home, drawing hot air from the upper zone where heat accumulates. The top of the pipe exits through the wall or roof above the roofline, open to the sky. Seal all joints with standard PVC cement to prevent air leaks. Install the screened intake at the bottom to prevent insects from entering. Paint any exposed non-black sections matte black to maximize solar absorption. Open windows or vents on the north, east, or shaded side of the home to provide the cool air inlet that feeds the chimney draft. The system works through pressure difference. The chimney creates low pressure at the top. Outdoor air enters through the lowest pressure intake point, which should be the coolest, shadiest opening available. Run the system during daylight hours. Close north-facing openings at night to retain any coolness accumulated. In the morning, open everything again as the sun begins heating the pipe. For maximum performance, increase pipe diameter to 6 or 8 inches and pipe height to 12 feet or more. Larger pipe diameter and greater height both increase airflow dramatically. A 12-foot section of 6-inch black pipe mounted on the highest point of a south wall creates enough thermal draft to continuously ventilate a 1,000 square foot home during peak solar hours. Total cost for a complete optimized system, under $25. For even greater performance in extremely hot climates, add a thermal mass element to the system. Stack dark-colored stone, brick, or water-filled containers against the south wall near the base of the chimney. These materials absorb solar heat during the day and release it slowly into the airstream, feeding the chimney draft, extending the ventilation effect into the early evening hours, even after the sun drops below the horizon. A homesteader in New Mexico installed a 12-foot black pipe system on his south wall last summer. Outdoor temperatures averaged 95 to 105 degrees from June through August. Before the system, his indoor temperature reached 88 to 92 degrees by late afternoon in his uninsulated cabin. After installation, afternoon indoor temperatures stayed between 75 and 80 degrees on the same days without any mechanical cooling. His summer electric bill dropped from $180 per month to $40 per month. He has not run his window unit since May. $12 in pipe. One Saturday of installation, $140 per month in electricity savings. Every month, every summer, forever. Let me state these numbers one final time. A $2 black pipe mounted on a south-facing wall creates a thermal draft that reduces indoor temperatures 10 to 15 degrees and ventilates a home continuously during daylight hours with zero electricity consumption. The same thermodynamic principle cooled Persian palaces in 115-degree desert heat 3,000 years ago. Roman architects documented it. The Department of Energy published it. Oak Ridge National Laboratory tested and confirmed it. A central air conditioning system costs $5,000 to install, $200 per month to run, and $2,000 to repair when it fails. Over 30 years, total cost exceeds $80,000. A solar chimney costs $12 in materials, takes one afternoon to install, and runs for free for decades. The $130 billion cooling industry needs you to believe that temperature is only manageable through a machine, a refrigerant, and a monthly payment. The Persian desert cities that have been continuously inhabited for 7,000 years prove otherwise. Your ancestors stayed cool for free. Then an industry convinced your generation that cool air must be purchased. But today, sitting right here, you just learned how to take it back. If this video opened something for you, subscribe and share it with every person you know who has ever opened a summer electric bill and felt sick. Every share preserves what they spent decades keeping off your wall and your radar. The next video drops soon. What is inside weighs even heavier.